Hello everyone. The title of the project is Such Infinity Controller for Buck Boost Converter. The main objective of this project is to model an interleaved buck boost converter and to design a robust voltage controller, that is Such Infinity controller for a buck boost converter, and to simulate the converter with the H infinity controller and to analyze the simulation results. Usually in conventional DC-DC converter, it contains high current stress, similarly high ripple in both input and output part. To overcome these disadvantages, interleaved buck boost converter is used. Interleaved buck boost converter is nothing but a parallel connection of buck boost converter, which gives greater advantages like greater reliability, power quality is improved, and it has lower losses. System can be improved by interleaving the operation of a parallel converter. Here, this is the interleaved buck boost converter. Here as a source I have used AC source, and it contains two switches, two diodes, capacitor and inductors. The output of PI controller is given to AND gate along with the pulses from the pulse generator, and the output from the AND gate is given to a both the switches in the interleaved converter. And this subsystem is the load part. Here in this project as a load I have used BLDC motor. In BLDC motor, the torque production takes place through attraction and repulsion between the stator and the permanent magnet in the rotor. Both when these fields are in 90 degree, the maximum torque production is possible. So to energize the correct stator winding, the rotor position must be known. For this, we have used Hall effect sensor. The main motto of Hall effect sensor is to mount on either on stator or rotor part, which is usually known as 6-step commutation. So here there are 6 switches here for giving information exact position about the rotor, and the output from this PI is given to this subsystem as one input, and the stator EMF is given to the another input to the subsystem. The subsystem is nothing but H infinity controller which contains weighting functions. Weighting functions are nothing but the control knobs. Through adjusting these weighting functions, the robust performance and the robust stability is obtained. Here are the results. This is the singular value plot of weighting functions, and this is the Bode plot which indicates the gain and the phase origin, and this is the root locus. Here you can see the arrangement of poles in the left half part, so that it can be said that the system is stable. And here is the pulses of for the two switches and the current through the inductor 1 and 2, and this is the source voltage, source current, and the load current. Here is the load voltage. Here in this project, boost operation takes place. That is the output voltage is higher than the input one, and the output voltage of the load precisely meet out the set point as designated. Thus, H infinity controller enjoys to be robust voltage controller. And the rotor speed in the second graph, it indicates the speed of the BLDC motor, and the set speed of BLDC motor is changed from 500 to 1000 for 2.5 for 0.25 seconds. The motor is able to track the set speed effectively with H infinity controller, and it can be concluded that using H infinity controller, it encourages result, and robust performance and robust stability of the system is obtained. Thank you.